Bismillahirrahmanirrahim. Welcome to Dr. Tess Academy. My name is Engineer Rahman Ali Khan. Let's start the lecture number 6 of Building Construction Engineering. So in this lecture, we will do the general introduction of brick masonry construction and different terminology we have to define which is used in the brick masonry construction and types of brick masonry bond and its types, tools used in the brick masonry construction, general principles and precaution in brick masonry, and in the last we will discuss the defects in brick masonry and its maintenance. Brick masonry construction. Brick masonry. So an example of a brick properly bonded together in mortar is called brick masonry or brickwork. So in this type of masonry, the brick are arranged and bedded in mortar in such a manner as to form a homogeneous mass of the structure. In such a structure, the point or other load and stresses are dispersed and distributed throughout the mass without disintegration of the structure. So the mortar to be used in brick masonry may be mud mortar, lime mortar, or cement mortar, depending upon the class and strength of the work desired. The brick masonry is commonly used for construction work of ordinary as well as important buildings and other structures in area where natural stones is not obtainable cheaply and abundantly. So this is the example of brick masonry. This is Islamic college which is built from brick. So brick masonry is one of the oldest construction method and it is used still in many parts of the world. And according to a survey made by Department of Civil Engineering, UT Peshawar, about 70% of the building stocks consist of brick masonry. And the advantages of the brick masonry are it is low cost and the brick is available nearby everywhere and the construction of brick masonry is simple. So these are the advantages of the brick masonry. Now let's discuss different terminology which is used in the brick construction. So number first one is brick. So brick is an artificial machinery unit in the form of rectangular block of prepared clay is called a brick. So now you will be thinking that how the brick are manufactured. So brick are manufactured by molding brick or in rectangular blocks of uniform size and shape, and then by drying or burning these blocks in a suitable flame or kiln. The bricks simply dried in the sun are known as sun-dried or kacha brick, and those burnt in a kiln or kiln are known as burnt or pakka bricks. So bricks are burnt to provide them strength and durability. So depending upon the quality of or the material of brick, it is classified as first class, second class, and third class brick. You can see the picture of brick. Now you will be thinking that oh, what should be the size of brick? So the nominal size is of the brick are an inch or 9 cross 4.5 cross 3, but the actual size is less than the nominal size. So the actual size is this. Number second is fork. So the depression which we provide in a brick is known as void. So what is the purpose of providing a fork in a brick? So the purpose of a fork is to form a key motor in between any two adjacent courses and to reduce the weight of the brick so that it can be laid with convenience and to provide a place for putting impression of trademark. So these are different components of the brick. This is the stretcher face, this is the header face, and the corner of the brick are known as areas or edge. So number four is brick on bed. So when the brick is laid in such a position that it's laid on a one of the bed is known as brick on bed. and brick on sides when the brick is laid on one of its stretcher pads known as a brick on sides. You can see in the figure that it's laid on one of the face which is known as stretcher face, and it's also called brick on edge. Brick on end, when a brick is laid one of its end in that position is known as brick on end. You can see in the figure. Course. So a layer of bricks and brick machinery is known as courses. So you can see this is the stretchers face, this is the header face. So the course are of two types, uh, stretcher course and the other one is header course. So when the brick are laid in stretcher, that are known as stretcher course, and the stretcher course provide longitudinal strength to the wall, and the bricks when are laid in header are known as header course, and it provides transverse strength to the wall. Quine brick. So basically the mean of quine is the external corner of a wall is known quine. So the brick which we provide at the external corner of a wall is known as quine brick. So you can see in the figure that this is the external corner which is known as quine, and the brick is known as quine brick. So quine closure, uh, so the portion of a brick which we divided into two halves along its stretcher or length is known as uh, quine closure. So you can see in this figure this is a wall. So this is the external corner. The brick is known as quine brick, and this is the queen brick. This is the header course, and this is the stretcher course. Bed joint. So the horizontal mortar joint. These are the horizontal mortar joints which we provided between the two consecutive courses. So this is the bed joints, and the vertical mortar joints which we provided uh, between two bricks is known as head joints, which is perpendicular to the face of wall. Brick bed. So when we cut a brick along its width is known, so the portion is known as brick bed. So the brick bed may be half bed or three-quarter bed. King closure. So when we cut a triangular portion from a brick, so the remaining portion is known as king closure, and it is usually used for forming proper bond and brickwork of oblique junction. Plinth machinery. So the machinery which we provide between the ground level and the plinth level is known as plinth machinery. James. So the vertical sides of upper doors or window which support doors or window is known as jambs. You can see in the picture this is the jamb. Soffit. So the bottom surface of a lintel uh, arch roof is called soffit. You can see in the figure this is the soffit, and the window this is the soffit. Sill. So the bottom of the window or door is known as sill. You can see this is the sill of the door, and this is the sill of the window. Column. It is an isolated load-bearing member, the width or the width of which does not exceed 4 times its thickness is known as column. So it may be constructed of any suitable material. Pier. So we provide this pier between the perforated wall. So it is an intermediate vertical portion of perforated wall between two openings. You can see this. This is a pier. So perforated wall means a wall in which intentional opening or perforation is provided. Spandrel. So the portion of wall which we provide above the opening or perforation is known as spandrel. Baluster. So it's a thick vertical member forming integral part of a wall. We provide the plaster to strengthen the wall in out of plane direction. Plane band. So a horizontal reinforced concrete which we provide throughout the length in a masonry at plinth level is known as plinth bed, and the horizontal reinforced concrete which we provide at lintel level is known as lintel band, and the horizontal reinforcement concrete which we provide at the roof level or eave level is known as roof band or eave band. Passing. So the external surface of wall is known as passing. This is the passing external surface, and the backing is the internal surface of wall, and hurting is the portion between the backing and passing is known as hurting. So this cornice. So it is a projecting ornamental which we provide at the building tops or at the junction of wall and ceiling. So you can see this is the cornice which we provide at the top of the building. Parapet. So the wall which we provide at the rooftop is known as a parapet wall. Coping. So it is a coarse placed upon the exposed top of an external wall which we provide the coping to prevent from the seepage of water. Toothing. So the temporary wall ends where alternate stretchers are project out. So the projecting masonry units are called tooths. So now let's discuss types of brick masonry construction. So there are three types of brick masonry construction. The one is unreinforced brick masonry, reinforced brick masonry, and the confined brick masonry. We will discuss each types in detail in the next slides. Unreinforced brick masonry. So unreinforced brick masonry is a type of masonry construction where brick are laid using mortar without any reinforcement. So it relies solely on the weight and bonding strength of bricks and mortar for stability. So the advantages of unreinforced brick masonry, it is a simple and cost-effective construction. It is suitable for low-rise building and non-seismic areas. Requires minimal skilled labor. Reinforced masonry. So a masonry system where steel's reinforcement is embedded within the brickwork and surrounded by mortar or concrete to improve structural strength and ductility. You can see in the picture that the vertical reinforcement is provided in a brick wall. Here you can see that the vertical reinforcement is provided, and here you can see that the horizontal reinforcement is provided. So the advantages of reinforcement masonry, it increased strength and load bearing capacity, improve resistance to seismic force, and suitable for high-rise and heavy load structures. And the brick masonry, we use the hollow brick confined masonry. So a type of masonry where vertical and horizontal uh, reinforcement concrete elements are added. You can see in the figure that reinforcement confining elements are used to confine the masonry. So the advantages of the confined masonry are its better performance in seismic zone due to increased confinement and prevent sudden collapse. So it's improved safety and it is cost effective. You can see this is a confining a masonry image. Now let's discuss brick masonry bond. So brick masonry bond is simply defined as the arrangement of brick in each layer so as to avoid continuity of vertical joint and any two adjacent cores both on the base and inside of masonry structure is called bond. So the primary object of providing bond is to break the continuity of the vertical joints in the successive courses and in the length and thickness of a masonry structure, and to ensure a longitudinal and lateral strength of the structures, to enable the structure to act as a bonded mass and to distribute the load uniformly to its function, and to provide pleasing appearance by laying bricks or structures systematically, to do masonry work quickly by engaging more masons on the job at a time. So now let's discuss bond types. So there are different types of the bonds, such as English bonds, Flemish bonds, stretcher bond, header bond, garden wall bond, racking bond, English cross bond, Dutch bond, monk bond, zigzag bond, brick on edge bond, silver log bond. So we will discuss each in detail in the next slides. English bond. So the bond having header and stretchers laid in alternate courses is called English bond. So you can see in the figure that this is the stretcher course and this is the header course. So we provided the stretcher and the header course in alternate courses. So the suitability of English bond is commonly adapted for brickwork building where length is of where strength is of prime importance. So now let's discuss the silent features of English bonds. So header and stretchers are provided alternatively, and a queen closure is provided after every queen header. So the same courses will show headers or stretchers on the face and back if the thickness of wall is even multiple of the half brick. And the same courses will show header on the face and stretchers on the back, and vice versa if the thickness of the wall is an odd multiple of the brick. Second one is Flemish bond. So the bond having headers and stretchers laid alternatively in the same course is called Flemish bond. So you can see in the figure that this is a stretcher brick, face of the brick, this is header, and we provide the stretcher head alternatively in the same course in all on the wall. So this is a Flemish bond, and you can see the queen closure is provided after every queen header. So this type of bond is mainly used in Europe, and this has two types. One is single Flemish bond and the other one is double Flemish bond. So single Flemish bond. So the bond provided in a wall with Flemish bond in facing and English bond in backing is called single Flemish bond. You can see in the figure, this is the uh, top view of the uh, plane. This is a plane view, and you can see this is a Flemish bond, and here you can see this is a English bond. So one side is Flemish bond and the other side is a English bond, and you can see in this picture this is the Flemish bond and this is the English bond. So this type of bond is known as single Flemish bond. And the double Flemish bond, the bond having headers and stretchers are alternatively in each course, both in the base and back of the structure is called double Flemish bond. So the double Flemish bond, you can say that the uh, backing and facing is the same. We have provided two Flemish bonds at each base. You can see in the figure that this is the plane view. So here you can see the Flemish bond, and here you can see the Flemish bond. So now let's discuss the comparison between English and Flemish bond. So you can see in the table that this is the English bond and this Flemish bond. So alternate stretchers and headers courses and here in same course we provided the alternate header and stretchers. So English bond have strongest of all bonds and less strong for wall thickness greater than 1.5 brick length. The third comparison is a rough appearance, especially for more brick thickness, and it has good appearance for all thickness. Number four comparison: no continuous vertical joints, partly continuous vertical joints in English and Flemish bond. So special care is not required in English bond, but in Flemish bond, special care is required. So in English bond, the progress of work is more, and in Flemish bond, the progress of work is low. So brickwork are not used, therefore it is costly. And here we provide the brickbats, so it is economical bond. Stretcher bond. So the bond having all the bricks laid is stretcher in every course is called stretcher bond or stretcher bonds. So you can see in the figure that here we provided all the bricks and stretchers. So that's why it's called stretcher or stretching bond. Here we provide the brick bed to break the bonds, and this type of bond is suitable for half brick thick wall and is commonly used for constructing 10 centimeter brick thick partition walls and header bonds. So the bond having all the brick laid as headers and every course is called heading bonds or header bond. So here we provide a 3/4 bed at point to break the vertical joints, and the bond is used for constructing a cornice wall in Wales. Garden wall bond. So the bond used for constructing compound walls of a garden is called garden wall bond, and it is also called boundary wall bond. So this type of bond is used for constructing thick garden walls, boundary wall, compound wall. So the garden wall have two types. One is English garden wall and the other one is Flemish garden wall. So English garden wall, uh, the garden wall bond in which a heading course is provided after 3 or 5 stretching course is called English garden wall. And the Flemish garden wall, the garden wall bond having a header provided after 3 or 5 stretchers in each course is known as English Flemish garden wall. Racking bond. The bond having all the bricks laid at an angle to the facing and backing of a wall is called racking bond. Racking bond have two types. One is herringbone bond and the other one is diagonal bond. You can see in the picture this is the herringbone bond, and the herringbone bond can be defined as the racking bond having bricks laid in at angle of 45 degree starting from the center line and proceeding towards the facing and backing of the wall is called herringbone bond. So this type of bond is used for hurting the walls having thickness more than 4 bricks. The second one is diagonal bond. So we can define the diagonal bond as the racking bond having brick laid at a suitable angle to the facing and backing, and parallel rows starting from the corner of hearting of the wall is known as diagonal bond. So this type of bond is suitable uh, for hearting the walls having thickness of 2 to 4 bricks. English cross bonds. So the bond having headers and stretcher laid in alternate courses. You can see in the figure that this is the stretcher course and this is the header course, and we provided alternatively. So and a header provided after the coin stretchers. So you can see this is the stretchers, coin stretchers, and we provided header after coin stretchers. And every alternate stretching course is called English cross bonds. So this type of bond is also called in-reef cross bond, and it is similar to English bond. And you can see in this figure that we provided the queen closure after every coin header. So this type of English cross bonds is suitable for brickwork where both strength and appearance are required, but is not very common in brick masonry. Dutch bond. The bond having headers and stretcher laid in the alternate courses. You can see in the figure this is the header course and this is the stretcher course, and we provided throughout the wall in alternately. So, and every stretching course started with a 3 by 4 brick bed. You can see in the picture that every stretcher course is started with a 3 by 4 stretching course. You can see alternatively is known as Dutch bond. So this type of bond is not very common and is used only for brickwork where strength is of prime importance. Monk bond. So the bond having two stretchers and one header laid alternately in each course is called monk bond. You can see in the figure we provided two stretchers and one header, two stretchers and one header in each uh, courses. So this is a monk bond, and monk bond is used in the construction of boundary walls where bricks of inferior quality are to use for the backing. Zigzag bond. So the bond having bricks laid in a zigzag fashion is called zigzag bond. You can see in the figure. So this type of bond is suitable or commonly used for paving the brick floors. Brick on edge bond. So this bonds having all bricks laid in their edge is called brick on edge bond, and this type of bond is suitable uh, with bricks and FPS system for the construction of garden walls, compound walls, partition walls. Silver lock bond. The bond having bricks laid in ultimate courses in such a way that headers are laid in bed and the stretchers are laid on edge, forming a continuous cavity throughout length of the wall is called silver lock bond. So you can see uh, that the headers are laid on beds and the stretchers are laid on edge. And here a cavity is formed between the two stretchers which place on the edge. So this type of bond is known as silver lock bonds, and this type of bond is suitable where bricks and FPS system for the construction of garden wall and partitions, etc. So now let's discuss different tools used in the brick masonry construction. Trowel. You can see in the figure this is the trowel image, and this is used for spreading and shaping mortar during bricklaying. The second one is brick hammer. So the brick hammer used for cutting and chipping bricks or stones. And the third one is pipe level. You can see this is the pipe level picture and ensures proper leveling of pipes in plumbing work. And the fourth one is plumb bob. So plumb bob is used to check vertical alignment and constructions. And straight edge, so used to check surface flatness and alignments. And this is the water level. Water level is used to measure level difference over long distance. And this is the small tapping tape measure short distance accurately. And this is the Mason squares, ensure accurate right angles in masonry work. And the last one is strength, which is used and helps in aligning bricks and leveling surface. General principle and precaution and brick masonry. So the following principle and precaution should be generally considered in brick masonry. Material. So the material first we have to check the bricks. So brick to be used for masonry work should be well worn and of a uniform size, shape, edge, strength, texture, and soaking. And the mortar which we use is mm, the mortar which we use is of good quality, and the junction of wall should be properly bonded, and there should be proper construction of the corner and T-junction, proper joints, fillings, uniform thickness of the mortar joints, level of courses and verticality of walls, per deck construction height less than 1 meter for half bricks and 1.5 meter for one brick wall, and there should be proper curing 1 to 2 weeks depending upon weather. Now let's discuss defects in brick machinery. So the common defects of brick machinery are discussed below. Number one is dampness, corrosion of metals, effects of sulfates, frost actions, and efflorescence. Dampness. So dampness is the state of diffuse moisture in air on a surface or in a solid. You can see this is the dampness. So So we can avoid the deafness by or control by dam-proof coats and surface treatment. Corrosion of metal. So the corrosion and the deterioration of metal due to the chemical reaction with their environment. In construction, metal elements such as steel reinforcement in concrete structures, steels and fasteners and are, are vulnerable to corrosion. So the corrosion occurs when metal reacts with oxygen and moisture forming rust. In the case of steels, chlorides form de-icing, salts, seawaters, or contaminated cores can be accelerated corrosion. Carbon dioxide in the air reacts with concrete, reducing its alkalinity and making embedded steels vulnerable to rust. So the effect of steel corrosion uh, is loss of the structural strength and durability, expansion of rust leading to cracking and spalling in reinforcement concrete, and it increase the maintenance cost and reduce lifespan of the structures and potential failure of the metal connection and fasteners. So to overcome these effects, the iron or steel member should be properly protected with rich cement mortar. Now let's discuss effects of the sulfates. So sulfate attack is a chemical reaction that occurs when concrete or masonry structures are exposed to sulfate-rich environment, such as soils or water with dissolved sulfates. So the effect of sulfate is the formation of expensive compounds like gypsum, causing expansion and cracking, loss of the strength and durability, and the disintegration of mortar and brickwork are occur, and spalling and flaking of the concrete surfaces. So in order to overcome these defects, the brick having sulfates content should mit- should not be used in the brickwork, and also the dampness be prevented as much possible. Now let's discuss frost action. So frost action refers to the damage caused by the freezing and thawing of water within building materials, especially in cool climate. So the effect of this action is expansion of frozen water left the ground, causing uneven settlements, scaling and spalling, cracking and disintegration, reduced durability. So in order to overcome this defects, accumulation of water should be prevented and good quality bricks should be used for the construction. Efflorescence. So efflorescence is the white powdery deposit of salt that appears on the surface of brick, mortar or concrete. So to overcome this defect, sound bricks and good mortar should be used. The brick work should be protected against contamination with salts, and the damp-proof course should be well designed because the effects of the efflorescence uh, is uh, is aesthetic issues, weakening of mortar joints due to the repeated salt crystallization, and increased porosity, making masonry more vulnerable to moisture damage. So we have to overcome this defect. Now let's discuss maintenance of the brick machinery. So the act of upkeeping any brickwork is known as maintenance of the brick machinery. So the following work are generally executed for proper maintenance of the brick machinery. Number one is cleaning brick machinery. So the dust and growth of the organic um, methods, if any, is to be removed occasionally to ensure the neat appearance of brickwork. The second one is removing efflorescence. So a white uh, layer gets deposited over the surface of the brick due to the crystallization of salts. So this white layer provides ugly look to the wall and may cause disintegration of the brickwork and therefore must be removed. And the third one is reconditioning the brick machinery. So the mortars and the joints gets lost or the plasters scales up from the surface of the brick. machinery under the effects of the rains and other weathering agency. So to ensure neat appearance and to make the surface watertight, reconditioning of the surface is done either by pointing or plastering as desired. And the fourth one is repainting the brick machinery. So the rainwater along with dissolved salts may rise up and cause dampness in the brickwork. So this dampness may disintegrate the brick and turn them into powder. It also scares off ugly appearance. To overcome this tendency of dampness, the surface of brick machinery is to be repainting after drying. So thank you for hearing me. If you have any question, you can ask and comment.